the vibration of polyatomic molecules. Now consider a molecule containing n atoms. Thus the total number of coordinates in 3D is 3n. We know that. We said that the molecule has 3n degree of freedom. So if we are having n atoms in 3D, then there will be 3n translation motion. So there will be translation motion will be 3n minus 3. So just remember, there will be always 3 translation motions. 3 translation motions. I am very happy by that. Okay. Now let's move forward. Okay. Now remaining rotation in 3 perpendicular directions to each other. These remaining degrees of freedom can be associated with different mode of vibrations. So we were having, just remember, translation degrees of freedom 3 minus 3, total is 3 and translation is 3. So remaining is 3 in direction perpendicular to each other. Remaining degrees of freedom can associate with the different. Okay. Now for linear molecule, what will we have? For suppose we are having total 3 and for translation is 3. So for linear molecule, degrees of freedom for fundamental vibration will be 3n minus 5, and for non-linear it will be 3n minus 6. Getting my point or not? Just remember this, okay? 3 is always minus for translational, and for linear molecule then it will vibrate in 2 directions. So 3n minus 3 plus 2, 3n minus 5. And if it's non-linear, then it will be in 3. So 3n minus 3 minus 3, 3n minus 6. Got my point? Linear and non-linear. There will be 3 for translation. We know this. So 3n minus 3 always will be there. And for linear, 2 more. So 3n minus 5. And for non-linear, 3n minus 3 minus 3. So 3n minus 6 for non-linear. Now in both cases, n atom molecule has n minus 1 bond. Bond कितने? n minus 1. For acyclic molecule between its atoms, n minus 1. अगर acyclic हो गया तो कितना होगा? n minus 1 vibration bond हो जाएंगे along the bonds which we call stretching. 3n minus 5 minus n minus 1. Just now let's continue for 5 minutes more. 3n minus 5 minus n minus 1 for linear means n minus 1 vibration bond for stretching. It is for stretching, and for this is for. So be 2n minus 4, 2n minus 6 for linear, 2 for non-linear. Rest 2n minus 5 vibration for bending motions for non-linear. For non-linear 2n minus 5, and for linear 2n minus 4. Okay. Now for diatomic molecules, n equal to 2, suppose it is linear. So fundamental mode of vibration will be 3n minus 5. How many? 3n minus 5. Suppose this is linear, and this 3n minus 5. So stretching will be n minus 1. And if stretching is 1 minus 1 and this is linear, then it will be 2n minus 5 for bond. So 2n minus 5 means how many will be there? 1 minus 1 equal to 0. Okay, so 0. And for H2O, it is non-linear. For non-linear, 3 minus 6. So 3 into 3 minus 6 equal to 3. For bond stretching, n minus 1. N is 3 minus 1. And 3 to 5. And total is 3 minus 2 equal to 1. This symmetric, this anti, this is also for cyclic जो अपने वाइब्रेशन स्ट्रेचिंग वाले स्ट्रेचिंग और बेंडिंग में उसमें क्या है सिमेट्रिक एंटी सिमेट्रिक भी है ना ध्यान रखना है. Now for CO2 for n equal to fundamental is linear is 3 minus 5 which will be 4. Now bond stretching vibrations will be n minus 1, n minus 1 3 minus 1 equal to 2 for acyclic. For bond bending vibration remaining 4 minus 2 minus 4 equal to 4 minus 2 equal to 2. And among these 4, what will be there? 2 for bending and 2 for stretching, be symmetric and unsymmetric. And this is the line which bisect HOH angle of the rotated molecules about H. Just read, have a read. And this is symmetric axis, this is symmetric bending, this is mu parallel, this is mu 2 parallel, frequencies are there, this is antisymmetric, mu 3 parallel. Now let's focus on this. Mu 3 antisymmetric stretching always is greater than mu 2 symmetric. And so first of all, symmetric is greater than stretching. Symmetric is greater than stretching. So symmetric stretching will be in middle, antisymmetric, and symmetric. Now these three vibrational motions are known as normal modes of general. In normal modes of vibration is defined as molecular motion in which all three atoms have motion with same frequency and pass through the equipositions simultaneously. Since all these three vibrational motions of H2 asserts with the dipole moment change, so all three vibrational modes of H2 are vibrational irreactive. This CO2 you can check. This symmetricity, move symmetric is greater than move centrimeter, stretching is greater than bending. Again same. Now the influence of rotational of the spectrum of polyatomic. Now suppose the linear molecule we having, so parallel vibration for selection rules are these. Now how many, there is much content for you, there are many selection rules for you. So now problem is how you differentiate. So by reading continuously, daily revise, and then you will have clear cut idea about where we use what thing. परपेंडिकुलर मोशन में क्यू ब्रांच ऑब्जर्व नहीं होगी. Now nuclear spin, this is important. The center of symmetry if we are having, then we said is that effect of nuclear spin will be observed in R line. This is due to the existence of nuclear spin and the additional factor determining the population of rotation. In the present example of CO2 has center of symmetry, the effect of nuclear spin every alternate rotation layer is completely enough. So alternate lines P and R branches are 0. This needs to separate spacing between 4p instead of 2b. So in nuclear spin we are having spacing 4b as compared to 2b. बस ये याद रखना है. And this CO2, if this is isotope is different, then what will happen? No center of symmetry. So in this condition there will be no effect of nuclear spin, and if no effect of nuclear spin, the separation between p and I is 2b, and if effect of nuclear spin both are 16 or both are 18, then center of symmetry will be there, so separation will be 4b. This is the more important part. Thank you very much.